Hello everyone, Ling Yanjing here, and my student ID is MAT2509051. So in this video, I'm going to talk about the irrationality of the square root of 2. But before explaining the topic, I will explain how the number system works. So in this slide, we can see that the most basic number system is the natural number. Natural number starts with 1, 2, 3, 4, and so on. They're also known as positive integers. Outside natural numbers, we have integers, which contains natural numbers but also includes 0 and negative integers. Outside of integers, we have rational numbers. But what are rational numbers and what are irrational numbers? Well, I'll get back to that later. So we all know that all rational numbers and irrational numbers, we call them as real number. But real number are not represented as all numbers. As we all know, outside real numbers, we have imaginary numbers whose numbers have I in them. So where a number has a real part and an imaginary part is a complex numbers, which is defined as a plus bi, where a and b are integers. A is the real part and bi is the imaginary part. So you might even wonder, where are the transcendental numbers? So, well, transcendental numbers like e or pi are a number that have infinite and non-repeating decimals. Since it can be either real or complex and it's not directly related to my topic, I'll just skip that part. Now I wanted to talk about some concepts to help understand my topic better. The first concept is what's odd number and what is even number. Well, an even number is the number that is divisible by 2, which means it has no remainder, like 2, 0, -8, and so on. And yep, 0 and negative integers are counted. On the other hand, an odd number is a number that is not divisible by 2, which means it has a remainder after divided by 2, like 1, -7, and so on. Remember this one. This concept takes a big role in the topic. The next concept is relativity prime, which is 2 or more numbers do not share the same factors other than 1. For example, like 15 and 16. 15 has factors 1, 3, 5, and 15. 16 has 1, 2, 4, 8, and 16 as the factors. So neither 15 nor 16 share the same factors other than 1. So they are relatively prime. However, for example, 12 and 21 are not relatively prime, since we know that they share the same factors, which is 3. Remember, the concept is important. So next concept I want to talk about is the unit digit. Unit digit is the digits that in one's place of a number, also known as the rightmost digits. Just take a look at the number 2578. 2 is in the thousands place. 5 is in the hundreds place. 7 is in the tens place. And then 8 is in the ones place, also known as the unit digits. So if the numbers is square, like 1 is odd number, 1 square equals 1, 1 is also an odd number, 2 is even number, 2 square equals 4, 4 is also an even number, 3 is odd number, 3 square equals 9, 9 is also an odd number, 4 is even number, 4 square equals 16. Since we know the 16, the unit digit is 6. So 16 is an even number. The list goes on, but we realize that after 10, beginning with 11 until 20, it has the same pattern as we square 1 to 10. So we know that a number is an odd number after being squared if and only if the number is odd, because the unit digit is an odd number. And then a number is an even number after being squared if and only if the number is even, because the unit digit is an even number. Remember, this one is so important. So the last concept, but not least, is what is a rational number? Rational numbers must fit with this condition. The number can be expressed as a over b in its lowest possible terms, where a and b are integers and b is not equal to 0. It's important. B is not equal to 0. So the rational numbers, the example is in the slide shown. And also, the rational numbers, they also must be a number that can be written in decimal forms, like finite decimals like 0.65, and repeating decimals like 0.3333, and so on. All right, so the concepts are clear, and I want to get straight into the topic, which is I want to prove that the square root of 2 is irrational. Square root of 2 is irrational. So we prove by contradiction. We use proof by contradiction. We assume that square root of 2 is rational. Square root 2 is a over b in the lowest term, where a and b are integers and b is not equal to 0. So that square root 2 is equal to a over b. So next step, we want to square both sides. Square of square root 2 equal to square of the entire a over b, and eventually become 2b squared equals to a squared. So like I said, a squared equals to 2b squared. So a squared must be even. And then since we just said that if a number after being squared is even, then the number is even. So a is an even number. Then we let a equals to 2c. So the square of 2c equals to 2b squared. And it will become b squared equals to 2c squared. Therefore, we know that b squared is even, and hence b is even, like I just said. So after the steps, we know that a and b are even numbers, which means a and b are divisible by 2. Notice anything? Well, you know that both are divisible by 2 means that they share the same factors, which is 2, and they are not relatively prime, since two numbers are relatively prime when they do not share the same factor other than 1. So the square root of 2 cannot express a over b as a lowest term. Lowest term means a and b must be relatively prime. But since a and b are even number, a and b is not relatively prime. Therefore, we can say that the square root of 2 is irrational. So after my explanation, you might wonder why proving a number is irrational so important. Well, it's because it can complete a real number line. We know that the real numbers do not only contain rational numbers. Since square root 2 appears, it's the first time that we encounter a number that's not rational. So we can only put the square root of 2 in the irrational number category. So the real number system is complete. And another thing is we can have proof techniques to prove that questions. Since we cannot use direct proof or proof by contraposition to prove that square root of 2 is irrational. So we must have a new proof technique to solve that to enhance mathematical understanding. So we use proof by contradiction to solve that the square root of 2 is irrational. Prove that perfectly. So that's all for my topic, and the video is going to end here, and thanks for watching.